In electronic systems and computing, firmware is the combination of persistent memory and program code and data stored in it. Typical examples of devices containing firmware are embedded systems, computers, computer peripherals, mobile phones, and digital cameras. The firmware contained in these devices provides the control program for the device. Firmware is held in non-volatile memory devices such as ROM, EPROM, or flash memory. Changing the firmware of a device may rarely or never be done during its economic lifetime. Some firmware memory devices are permanently installed and cannot be changed after manufacture. Common reasons for updating firmware include fixing bugs or adding features to the device. This may require ROM-integrated circuits to be physically replaced, or flash memory to be reprogrammed through a special procedure. Firmware such as the ROM BIOS of a personal computer may contain only elementary basic functions of a device and may only provide services to higher-level software. Firmware such as the program of an embedded system may be the only program that will run on the system and provide all of its functions. Before integrated circuits, other firmware devices included a discrete semiconductor diode matrix. The Apollo guidance computer had firmware consisting of a specially manufactured core memory plane, called core rope memory, where data was stored by physically threading wires through or around the core storing each data bit. Flashing refers to the overwriting of existing firmware or data on ROM modules present in an electronic device with new data. This can be done to upgrade a device or to change the provider of a service associated with a function of the device, such as changing from one mobile phone service provider to another or installing a new operating system. If firmware is upgradable, it's often done via a program from the provider, and will often allow the old firmware to be saved before upgrading so it can be reverted to if the process fails, or the newer version was worse. Origin of the term: Asher Opala coined the term firmware in a 1967 Datamation article. Originally, it meant the contents of a writable control store, containing microcode that defined and implemented the computer's instruction set, and that could be reloaded to specialize or modify the instructions that the central processing unit could execute. As originally used, firmware contrasted with hardware and software. It was not composed of CPU machine instructions, but of lower-level microcode involved in the implementation of machine instructions. It existed on the boundary between hardware and software. Thus the name firmware. Still later, popular usage extended the word firmware to denote anything ROM resident, including processor machine instructions for BIOS, bootstrap loaders, or specialized applications. Until the mid-1990s, updating firmware typically involved replacing a storage medium containing firmware, usually a socketed ROM-integrated circuit. Flash memory allows firmware to be updated without physically removing an integrated circuit from the system. An error during the upgrade process may make the device non-functional, or bricked. Personal computers. In some respects, the various firmware components are as important as the operating system in a working computer. However, unlike most modern operating systems, firmware rarely has a well-evolved automatic mechanism of updating itself to fix any functionality issues detected after shipping the unit. The BIOS may be manually updated by a user, using a small utility program. In contrast, firmware in storage devices rarely gets updated, even when flash storage is used for the firmware. There are no standardized mechanisms for detecting or updating firmware versions. Most computer peripherals are themselves special-purpose computers. Devices such as printers, scanners, cameras, USB drives, have firmware stored internally. Some devices may permit field replacement of firmware. Some low-cost peripherals no longer contain non-volatile memory for firmware, and instead rely on the host system to transfer the device control program from a disk file or CD. Consumer products. As of 2010, most portable music players support firmware upgrades. Some companies use firmware updates to add new playable file formats. Arriva added Volbee's playback support this way, for instance. Other features that may change with firmware updates include the GUI or even the battery life. Most mobile phones have a firmware over-the-air firmware upgrade capability for much the same reasons. Some may even be upgraded to enhance reception or sound quality, illustrating the fact that firmware is used at more than one level in complex products. Automobiles. Since 1996, most automobiles have employed an onboard computer and various sensors to detect mechanical problems. As of 2010, modern vehicles also employ computer-controlled ABS systems and computer-operated transmission control units. The driver can also get in-dash information while driving in this manner, such as real-time fuel economy and tire pressure readings. Local dealers can update most vehicle firmware. Examples of firmware include, in consumer products, timing and control systems for washing machines, controlling sound and video attributes, as well as the channel list. In modern TVs, EPROM chips used in the Eventide H3000 series of digital music processors. In computers, the BIOS found in IBM-compatible personal computers, the EFI-compliant firmware used on Itanium systems, Intel-based computers from Apple, and many Intel desktop computer motherboards, open firmware, used in SPARC-based computers from Sun Microsystems and Oracle Corporation, PowerPC-based computers from Apple, and computers from Genesee, ARCS, used in computers from Silicon Graphics, Kickstart, used in the Amiga line of computers, RTAS, used in computers from IBM, the Common Firmware Environment. In routers and firewalls, OpenWRT, Open Source Firewall Router OS based on Linux, MONOWARL, Embedded Firewall Distribution of FreeBSD, IPFire, Free Linux Router and Firewall Distribution, FLI4L Free Linux Router and Firewall Distribution. In NAS systems, NAS4 Free, Open Source NAS OS based on FreeBSD 9.1, OpenFiller, Free Linux-based NASOs. Firmware hacking. Sometimes third parties create an unofficial new or modified version of firmware to provide new features or to unlock hidden functionality. Examples include, Rockbox for digital audio players, CHDK and Magic Lantern for Canon digital cameras, Nikon Hacker Project for Nikon XP DSLRs. Many third-party firmware projects for wireless routers, including, OpenWRT, and its derivatives such as DDWRT, for wireless routers. RouterTech, a Euro for ADSL modem routers based on the Texas Instruments AR7 chipset. List of wireless router firmware projects. Firmware that allows DVD drives to be region-free. SamiGo, modified firmware for Samsung televisions. Many homebrew projects for gaming consoles. These often unlock general-purpose computing functionality in previously limited devices. Most firmware hacks are free and open-source software as well. These hacks usually take advantage of the firmware update facility on many devices to install or run themselves. Some, however, must resort to exploits in order to run, because the manufacturer has attempted to lock the hardware to stop it from running unlicensed code. Newer custom firmware hacks have also focused on injecting malware in devices such as smartphones. One such injection was demonstrated on the Symbian OS at MalCon, a hacker convention. Security risks. Mark Shuttleworth, founder of the Ubuntu Linux distribution, has described proprietary firmware as a security risk, saying that firmware on your device is the NSA's best friend, and calling firmware a Trojan horse of monumental proportions. He has pointed out that low-quality, closed-source firmware is a major threat to system security. Your biggest mistake is to assume that the NSA is the only institution abusing this position of trust. In fact, it's reasonable to assume that all firmware is a cesspool of insecurity, courtesy of incompetence of the highest degree from manufacturers, and competence of the highest degree from a very wide range of such agencies. As a solution to this problem, he has called for declarative firmware. Firmware should be open source so that the code can be checked and verified. It should also be declarative, meaning that it should describe hardware linkage and dependencies, and should not include executable code. See also. References.